Hi everyone, in this video I want to talk about solving systems of equations using substitution. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, let's think about the fun question. What was your favorite children's TV show as a small child? And on the math section under Algebra I, you see systems of equations and inequalities. You could have something referencing a graph. A question could ask like how many solutions would you have or something like that, but you would never actually be asked to graph a system. It's most likely that you would have to solve using either any of the three methods. Let's talk about those three methods. So substitution is what we're talking about here. You could also use elimination. And that method I have explained in a different video. There's also graphing. You could graph the two equations and see where they meet. But I highly doubt anybody would choose that method on the ACT. It requires a really specific and accurate graph. So let's just focus on substitution and elimination. So substitution is a process that involves trying to manipulate one of the equations so that you can solve for one of the variables and then throw that into variable in the other equation. So you have to make a decision to start, and that is which equation am I going to manipulate and which variable in it. So right away, I'm seeing that negative 2y, and I like the looks of the second one because all of these numbers are even. And if I get y by itself, like this, I can divide here and everything is even. So this would be negative 9 and then minus 4x. That's what y is equal to. So let's use our highlighters here for a second. So if I think of y as this now, then up here where I see a y, I can just sub in my new expression. So 7x minus 8 times the new y, because y is secretly negative 9 minus 4x, equals negative 6. Now, what I like about this is I'm now just solving for x. So let's put some little titles on what we're doing. This is isolate one variable in one equation. And there are so many different ways to do this. I just tried to do it the easiest way. The other ways would have involved fractions, which is fine. But if you can avoid them, it's great. This here is solve for one variable, and that would be x. You can only solve for one variable at a time. I would never be able to ask you to solve, an equation with two unknowns in it. You could isolate the variable by moving around the other variable, but you certainly couldn't ever solve, get an answer x equals 5 in either of these equations by themselves. So you need the two equations with the two unknowns to understand what x-y pair would work for both of the equations. That's what a system is. So I'm fishing for the x and y that work. It's like a needle in a haystack, but I have a tool, substitution, that can help me get there. So let's just keep on chugging here. 72 and then plus 32x equals negative 6. So this will be 39x equals, and then if I subtract 72, this would be negative 78, and then divide. Thankfully, that's just negative 2. So I get the one variable, and that is x. And then we'll say use x to find y. So how? Well, the x and y pair is supposed to work for both equations. So really, you can plug that x into either the first or the second one. But, I'm fairly confident about my work right here. Why don't I just plug it in right there? Y equals, and this is the manipulated version of the second equation. I'll just get y equals negative 9 minus 4, instead of x, negative 2. Let's do a little color coding there to make sure that pops out. This, if x is negative 2, there's the negative 2. The y, is equal to that. There's that x right there. So now we'll have negative 9, and then plus 8 is negative 1. So that magic xy pair that works for both equations is negative 2, negative 1. So if I plug in negative 2 and negative 1 for all of these x's and y's, my left side should equal negative 6, and my left side should equal 18 when I plug them both in. Now, let's try a problem over here. It's gonna be a little bit weird. So I'm including special cases here. Well, it looks like I can make the same decision here with that minus 2y. Oh, but that we have this 5x, and we will have a fraction or decimal for this one. So I'm trying to get y by itself. And why is that? Well, because if I try to get y by itself here, I would still have I'd have two fractions. Getting y by itself here would give me only one fraction I have to deal with. Getting x by itself here would involve two fractions. I'm just trying to take the easiest possible route. And that is getting 2.5x minus 3 for y. I'm going to choose to use a decimal because it's exact, rather than a fraction, just because I know I'm substituting and it's just a little bit easier. So now that I've manipulated the second equation, I want to plug that y in to the first equation again. 10x minus 4 times something new, 3 equals negative 2. 10x minus 10x plus 12 equals negative 2. Okay, these cancel. And then I get 12 equals negative 2. So here we have a special case. And let's write out what the conclusions would be at the end. So if you end up getting a true statement at the end, like 5 equals 5, then that conclusion would be infinitely many solutions. And then if I have a false statement, then the false statement would tell me that there are no solutions. This means that, like, for the first one, if you get 5 equals 5, that means that that you would have an infinitely many amount of solutions that could work in for x and y. Like, you wouldn't just get this one xy pair, you would get a lot of them. And then a false statement means that there's just nothing that would work for x and y. Nothing. No actual point would work. No xy pair. So in this case, this is not true. So this is no solution. Final answer. So no xy pair in the whole wide world could work. All right, let's go on to some practice problems. They are so similar to what I just gave you as examples. But what is fair game here are, just getting regular integer numbers or fractions or special cases. So why don't you try these, pause the video, and I'll reveal the answers. Okay, answers are here. So 6, 7 is the first one, and which is nice. And then the second one is infinitely many solutions, meaning that not just one point would work, but a whole line of points would work for the linear. And a quote for inspiration: humor is by far the most significant activity of the human brain. Really like that. So I hope this video benefited you in some way, and feel free to leave your answers to the fun question in the comments. And if you'd like to keep up with new videos, feel free to subscribe. Thank you.